Hi, everyone, and welcome to the 2016 Student Forum on Global Learning. I'd like to just take a quick minute to thank all of the student presenters, faculty moderators, and co-curricular educators who have dedicated their time and energy to really making this event possible. So thank you to everyone who played a role in bringing this event to life. This year's theme, Developing a World Perspective, directly builds on the work of Dr. Martin Luther King Jr., which is why we hold this event on this day. Dr. King challenged us. If we are ever to have peace on earth, our loyalties must transcend our race, our tribe, our class, and our nation. And this means we must develop a world perspective. The Dartmouth Experiential Learning Initiative, which launched this fall in 2015, in many ways is a direct response to that challenge. Our vision for the Dartmouth Experiential Learning Initiative is for Dartmouth to be a place of around-the-clock learning, a place where every experience contributes to building leaders with the wisdom for a complex world. What we are doing here today is part of that challenge and that initiative and the vision that we have for experiential learning. If we are to move forward, a phrase that we often hear at Dartmouth, then we must seek understanding beyond ourselves. What better way to do that than through intentional, reflective experience, critical reflection on those experiences, and sharing that learning through experience with other people? And that's really what this forum is all about. Moving forward also requires standing still sometimes. And that's also what today is about, and this forum is about. So we're here today to be still, to pause, and to give students a chance to really reflect on learning that they've had, to draw connections and make meaning of experiences that they've had here at Dartmouth and globally. So today, we pause and we give space to do that. In addition to reflection, experiential learning is also about discovery, as you will hear from our opening speaker, Professor Jerry DeSilva. Jerry is an associate professor of anthropology and adjunct associate professor in the Department of Biological Sciences. He's a paleoanthropologist, specializing in the locomotion of the first apes and early human ancestors. This fall, Jeremy was part of an international team of more than 60 scientists who found over 1,600 fossils of a new human ancestor in Rising Star Cave in South Africa. He joins us today to share the story of this discovery.
Thank you very much. Thank you for the invitation to be here to speak with you this morning. This is a really inspiring group. I was telling Ashley that I was looking through the catalog and the work that's being done by this group. The global learning that's being done here is just extraordinary and really inspiring. And hopefully I can set some context to this, because it's not just about a world perspective. For me, it's about a deep time perspective as well. And I'll get into that in some detail over the course of my talk. As Ashley mentioned, I'm a paleoanthropologist, so I'm interested in the origin and evolution of humans. I ask questions like, who are we? Where did we come from? And why are we the way we are? And in order to do this, I've had the really wonderful opportunity to travel and to go to fossil sites throughout the Great Rift Valley in Eastern Africa and Tanzania, Ethiopia, and Kenya. I've spent time with wild chimpanzees in Western Uganda, in their own habitats out there in the rainforest, really uncomfortable for us, great for them. And also, most recently, and what I'll talk about today, are fossils that we've discovered in cave deposits in South Africa. And so a lot of our work is focused there now. We're making these absolutely mind-blowing discoveries of fossils in South African caves. But as I was putting this talk together, what I was realizing is that there are some really wonderful parallels between the science that I do and what I do sort of day to day and what you all do as global learners. Because it's about adventure to some extent, right? It's about exploration and being curious about your world and then going out and seeking answers to some of those questions. It's about building a global perspective. It's about developing global connections with people around the world. It's about, to some extent, taking what you know, you already have in your brains, and applying it to new questions and generating new information and new ideas that may solve problems halfway around the world. But it's also about being curious and being good listeners and soaking up what others are doing and absorbing what they're doing to solve their challenges in order to go through what I think is a really wonderful intellectual exercise I would recommend to anyone, which is changing your mind at some point. You may go into these questions with a preconceived idea, and then new data, new evidence totally blows your mind, and suddenly you're saying, wait, I was wrong. That's really cool. It's a really fun thing to experience. It's not a discouraging thing. It's a wonderful thing. It's also, to some extent, about being uncomfortable and finding yourself in an uncomfortable situation, maybe having new opportunities presented to yourself that you say, woo, I'm not so sure about this, but then just diving into it and having wonderful experiences as a result. And I think the parallel that really draws me to this group is about self-discovery, where what I do explores who we are as a species and where we came from as a lineage, and global learning is all about discovering who you are as an individual and how you want to contribute to this world. And so with that as sort of my introduction to the talk, I want to dive into the science of this to some degree. So this here is a chimpanzee. This is one of the chimpanzees I had a chance to study in Uganda in 2006. This is my cousin. We are closely related to chimpanzees. We didn't come from chimps, they didn't come from us. That's not how evolution works. Instead, we share a common ancestor with chimpanzees. And I could study the genetics of that chimpanzee and take a sample from myself, and what it would reveal is that that chimpanzee and I shared a common ancestor, a great-great-great-great-great-great-great-great-great-great-great-grandparent, several thousand greats, that lived in Africa about 7 million years ago. Now, if this is true, if we have this right, then there should be fossils of things that are neither human nor chimpanzee found in ancient sediments in Africa. And they have been. We've got lots of these things. In fact, we have thousands of these things. Fossils of ancient humans. Rarely we get a really nice skull. And even more rarely, we get a skeleton. These are exceptionally rare items. Most of the time, we get isolated teeth, little bits of leg bone here and there, little bits of arm bone, and that's what we use as our data to generate our narrative, our story of human origins. Now, because we're talking about timescales in the millions of years, but discoveries in the thousands, and because a million is 1,000,000, essentially we have one fossil for every 1,000 years of existence. So imagine if I took your tooth, and that was the representative fossil for the last few thousand years of human existence. We'd be missing some information, right? There'd be some things we wouldn't be able to reconstruct about our ancestry. And so every time we make a new discovery, it really does uproot our understanding of human origins. It really does serve as a game changer sometimes when we make these new discoveries. It fills in gaps, but it raises all sorts of new questions we never even thought to ask prior to the discovery of these objects. Now, sometimes it's thought by many, and even some of my colleagues, think of this as just sort of this dusty old science, right? We find these old bones, and isn't that neat that we can discover these things about our ancestors? But I think what President Obama said about his touching of Lucy, he had an opportunity to go to Ethiopia in the summer, and he handled, this is a colleague of mine, Zariah Lemziged, and he handled the Lucy skeleton. And afterwards, he had these wonderfully poignant words, especially on today being Martin Luther King Day. He said, when you see our ancestor, we're reminded that Ethiopians, Americans, all of the people of the world are part of the same human family, the same chain. So much of the hardship and conflict and sadness and violence that occurs around the world is because we look at superficial differences as opposed to seeing the fundamental connection that we all share. This is beautiful. That's great stuff. And that's one of the reasons that I do what I do, is because by finding these fossils and revealing what they were like as ancestors, that tells us not just about them, that tells us about us. It tells us about the human condition today. It tells us about the human story, not just the folks living in Africa or Asia. It tells us about everyone, because we do share a common ancestry, all of us. So the story that I'm going to tell today is about two discoveries that have been made recently in South Africa. In South Africa, there are a series of cave deposits where openings in the ground, these vertical cave shafts, have served as places where bones in the landscape can sort of trickle down and be fossilized down at the base of these caves. This is an area known as the cradle of humankind. Many, many fossil sites that are shown here, and many more awaiting discovery. Now, colleagues of mine, Joe Kibbe and Lee Berger, in 2008, were quite interested in finding new caves. They wanted to find new cave sites in this heavily explored area. And to do this, yes, they were out on foot exploring this landscape, but when they were back in the laboratory, what they started to employ as a resource was something we've all become familiar with, and that's Google Earth. So they used Google Earth to fly into South Africa and have a look at bird's eye view of what the landscape looks like. And when you do enter into the cradle of humankind, it's very, very tan. It's light brown. You've got classic African savanna landscape, tall grass environment, and every once in a while in this otherwise arid landscape is a cluster of trees. And these are illustrated here with these red stars as we go through this animation. The question was, where are these trees getting their water? How are these trees sprouting out of the ground? And what they realized, what they surmised, was that the trees were growing from the caves. The caves were pooling water at their base. Seeds would fall in and then sprout out of these vertical cave shafts. And these clusters of trees were actually serving as bullseyes. They were telling you where the caves actually were. Job and Lee then went out onto the landscape to document the existence of these caves. And what they found were 300 new caves that nobody knew existed on this landscape. 300 of them. One of them is the one we're circling now, right here, that's known as Malapa Cave. If we take a closer view of Malapa Cave, it just looks like a hole in the ground. It doesn't look very impressive at all. This is the kind of place that I would have walked right past and said, just a hole in the ground, probably aren't many fossils here, and gone off to the next site. But at this site right here, 2 of the most complete early human skeletons ever discovered were found at this site, Malapa Cave. And the wonderful thing about this story, and it should be a story that you really absorb, that you don't necessarily have to be an expert to make a great contribution to this world. The fossils that were found at this site were not found by the paleoanthropologists Lee Berger or Joe Kibbe. They were found by Lee's 9-year-old son.
This is where I found it, and here's a rock that looks about the same size as it. And when I turned it over a bit, there was the clavicle sticking out. But when I saw it, I didn't know it was a clavicle.
So Matthew, your father was working around here, right?
Yes, he was.
And you went off wandering.
Yeah, I just followed my dog Tal down here, and then a big rock caught my eye. So I called my dad over, and when he was about 5 meters away, he started swearing. And he came towards me. He was like, it's a clavicle of a hominid. And I was like, whoa.
So most of the fossils that we find are fossils of antelopes and zebras and wildebeest and monkeys. Human fossils are really rare. But what was wonderful about this discovery was that the bone he found, the clavicle or collarbone, most mammals don't have, actually. It's pretty unusual. You wouldn't find it on a wildebeest. You wouldn't find it on a zebra or a giraffe or an elephant. Primates have this, and some other mammals have this as well. And the size and shape of it was a perfect match for a small-bodied human, and therefore a human ancestor. If there were any questions at all, the rock was flipped over, and on the other side was a lower jaw with a tooth sticking out of it. That was very clear in its anatomy to be similar to those of ancient humans. So this wonderful discovery made by a 9-year-old boy who, of course, was in the right place at the right time because his father was an expert and knew what sites to be at. But again, this is a place I would have walked right past. The rocks that were collected at this site all had bones sticking out of them. Okay? Bones are often found embedded within this fossilized soil that we call a breccia. And a lot of work at the laboratory was undertaken, months and months and months of preparation, of removing grain by grain the rock from around the bones. And when it was complete, we had these 2 absolutely extraordinary skeletons. On the right is a juvenile male. He was probably about 8 years old when he died. We can tell that from his teeth and from the lack of fusion of his bones. He was still growing. And on the left is presumably his mom, found in the exact same deposit, died at the exact same time, and it's an adult female who would have been in her 30s based on what we can tell about her tooth wear. We had never before in the history of our science found multiple skeletons at the same site. Lucy was found alone. Other fossils were found alone. These 2 were found together. We now had an opportunity to look at growth and development in an ancient species, to look at variation in what 2 skeletons of the same species might look like. This was an incredible opportunity. And what was really wonderful about these things is we had never seen this combination of anatomy before in an early human ancestor. Based on the shape of the brain and size of the brain, it's rather small, what the teeth looked like, rather human-like, a hand that was quite human-like in most respects, but a foot that was much more ape-like. This combination had never been seen before, and we named it a new species, Australopithecus sediba. This was announced to the world 6 years ago, 2010. What I've been working on mostly is how this thing moved, how it walked. And what we have found is that it walked unlike anything we had ever seen before. And it walked differently than humans walk today. It moved on 2 legs, yes, but it moved sort of with the twisting motion, twisting in of its hips and knees and ankle. It walked with style. Right? It was a great, great fossil. Based on its anatomy, we can tell that it moved in this sort of way. So we have this brand new creature that we didn't even know about prior to a 9-year-old making the first discovery. And so this was a wonderful, wonderful story of how in an area that you thought you had explored, we already thought we knew everything about the cradle of humankind, right in our backyard here is this incredible discovery of a brand new species. But remember, this was just one cave of the 300 that Lee Berger and Job Kibbe discovered. 300. So what about the other 299? Well, you could go out and explore those other 299 by yourself, or you could recruit the people who are really good at it and really like doing this, spelunkers. And there are spelunking teams in South Africa. And Lee Berger contacted many of these groups, and he said, here's my card. If you happen to bump into any fossils when you're spelunking through these caves, give me a call. Well, in October of 2013, these 2 guys here, amateur spelunkers, they're accountants other times during the day, but on the weekend, they like to go spelunking. This is Steve Tucker and Rick Hunter. And these guys were exploring a cave known as the Rising Star Cave Complex. And in that cave, there was a crevice in the wall in an area that they had explored before, but had never gone through that crevice. And one day they decided to go through the crevice. And they squeezed themselves through that crevice, and then they went down about 40 feet. And at the base of the chamber that they had entered, they saw that. Fossils, just lying there in the surface of the cave. Now, I told you earlier that fossils are often found encased within rock. We never find skeletons just lying there Indiana Jones style. That's not how our science works. And yet, there they are, right? And we could tell this wasn't a modern person because the teeth are actually getting bigger as you work towards the back of the mouth. The 3rd molar, the wisdom teeth, is the biggest of the teeth that we see there. In you right now, the 1st molar is the biggest. And the 2nd's a little smaller, and the 3rd is the smallest of the molar teeth. This is what ancient humans used to look like, having the 3rd molar the biggest. There's enough room back there because they were a little snoutier. So we knew right away we had an incredibly precious and rare discovery of a skeleton just lying there on the surface of a cave. We needed people to go down there and excavate this thing. But Steve and Rick couldn't do it because they didn't know anything about excavation techniques. They didn't know anything about anatomy. They weren't even sure that these were human bones or not, okay? So we needed people that had excavation experience, that knew how to dig up ancient human bones. We needed people who knew their anatomy and knew the difference between a human bone and a zebra bone and a monkey bone. We needed people who were comfortable in caves so that they would go down into the 100 feet underground and not completely freak out because they were claustrophobic, right? And we needed people who could squeeze through that crevice in the rock, which was only 7 inches wide. I want to show you what that looks like. Yeah, huh? So this is what I meant earlier about having a particular set of skills that you can apply to a unique situation, right? Who has that set of skills? These 6 women. We found the 6 human beings on Earth that could do this work. And there they are. We call them our underground astronauts. They came from all over the world. And they dropped whatever it was that they were doing to come to South Africa for 3 weeks and excavate these skeletons in November of 2013. They did an absolutely extraordinary job taking what was a dangerous situation and turning it into one of the most marvelous discoveries in the history of our science. They went twisting and turning through this cave complex. So you start up here and you walk down here. This is how far I got. I stopped right there. They continued on. And this is what's called Superman's crawl. So they had to, the reason is because they have to put their arm out this way and that way to make the fit. And that's 10 inches wide, so that's a breeze, right? And you get through that, and then you have to climb up Dragon's Back, which is filled with all these jagged and sharp rocks that was cutting away at their clothing and their skin. They get up here, and that's the 7-inch twist, so they have to squeeze through that 7-inch gap, and then there's a 40-foot drop. So they have to make their way through the chimney, which at least has walls that are on their edge so they can brace themselves as they're going down, but then they got to go back up the thing, right? And it literally is like going up and down a chimney. Then they make their way into the Dinalidi chamber where all those bones happen to be. They work in very difficult, hot, humid conditions. There were lights and cameras put down there, so not only could they have some lightings to see what they were doing, but so that the rest of us who couldn't fit down there could watch this on TV as it was happening 100 feet underneath the ground. And slowly but surely, they collected the fossils that were visible to them, wrapped them up in bubble wrap, put them all into a container, and send it back up the chute, where scientists at the surface would collect them, unwrap them, photograph them, document them, to try to figure out what it is that's down there. What creature is down there? And as this work was unfolding, what we realized was there were no bones from other animals down there. It was just the early humans. Okay? We had never seen a fossil site like that before. Always, 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 there are bones of other animals. Antelopes and zebras and wildebeest, the other animals that shared the landscape with whatever this thing was. And it was clear there wasn't a single skeleton. Initially, it looked like there was the one skeleton, but the bones kept coming up, and soon we had 2 right legs, then 3 right legs, then 4 right legs, and onward and upward. And soon we had 1,600 fossils from 15 individuals. To give you an idea of the magnitude of this discovery, in 3 weeks of work, those scientists excavated as many fossils as had been found on the African continent in the last 75 years. They doubled the human fossil record in Africa in just 3 weeks. This is an extraordinary, extraordinary discovery. And so we then went head to toe through this thing to try to figure out what it is. What is this creature? And compared to humans today, this creature had a much smaller brain, a brain about the size of a grapefruit, only about 1/3 of the size of humans today. It was snoutier than we are today, but its teeth individually were stunningly human-like. Each individual tooth looks a lot like yours and mine, with the only exception being what I already mentioned about that 3rd molar being larger than the other 2. This was an amazing skull, a very different kind of skull than what we had seen previously. And this is a replica of the skull. Small brain, snoutiness, and those individual teeth looking a lot like humans today. From the neck down, another combination we had never seen before. The shoulders were shrugged like an ape's. The chest was more like an ape's. The hips was like a Lucy. The knees and the ankle and the feet like yours and mine. The arms were long like an ape's, but the hands were like yours and mine, except the fingers were highly curved. Again, this head-to-toe combination we had never, ever seen before in an early human ancestor. And we named it a new species, Homo naledi. Homo naledi was announced to the world in September of this year, of last year, 2015, and it went viral. I mean, lots of people heard about Homo naledi. I was getting emails from students I had years ago. I was getting emails from teachers I had years ago, from relatives I hadn't heard from in years. This was a wonderful, wonderful moment for all of us doing this work, to see the recognition that these fossils got around the world and the celebration that these fossils got. There are many questions we still have about these things. We don't know where they fit in the family tree yet. We don't know if they are direct ancestors or if they're some extinct relative, some side branch of human evolution. And that's something that we continue to explore. But we're not afraid of these questions. Questions are fun to us. When we don't know the answers to something, we don't get frustrated. We say, cool, that's awesome. Let's go try to find out or find the evidence to answer these questions. One of the other big mysteries we have to Homo naledi is how it is that they all got down there in that chamber. There are 15 bodies and many more still down there yet to be excavated. We estimate that there are dozens of skeletons down there. We've only pulled up 15. And there are no bones of other animals. And we thought, okay, well, how do you explain this? Maybe there was some predator out there that liked to only eat Homo naledis and was grabbing them and dragging them down into this cave. Well, there are no bite marks on any of the bones, so it's not that. Maybe there was some catastrophic event where there was a bad flood that washed them all in, but there were no boulders and no sticks and no debris that you would get in a flood event. Well, maybe they all went down into this cave and just suffocated or starved to death. If that was the case, they would all be lying in the same geological layer, and they're not. They're actually stratified. The bodies are found on top of each other with sediment and therefore time between them. This happened over a period of time. The only explanation that we can come up with for now, our hypothesis, is that this small-brained creature was deliberately disposing its dead. That after individual members of its group died, they brought them down into this space, into this dark zone, and slid those bodies down that slot and into the chamber where they accumulated over time. That you have the ritualistic or repetitive disposal of the dead, something that we thought was uniquely human, happening in a non-human, happening in a species with a brain only a third of the size of yours and mine. This is a wonderful, wonderful discovery. And it's a discovery that we wanted to share with everyone. And so we made 3D scans of the 100 best preserved fossils, and we posted them to this source, morphosource.org. You can go on morphosource.org right now, download a 3D scan of these fossils, and print them out yourself with a 3D printer. You can have your own little Homo naledi fossil in your hand. Because these fossils are not ours. These fossils don't belong to South Africa, even though they're stored there. These fossils are everyone's. These are part of our story, everyone's story, and we wanted everyone to share in this story and be a part of this story and be able to have a Homo naledi fossil sitting on their mantle or sitting in their classroom and accessible at all times. And so I really hope that people do take advantage of this. We've had thousands of downloads of these fossils already. So I'm going to end with the following observation that brings it back, hopefully, to the idea of global learning. That these fossils, these roughly 2,000 fossils from just 2 fossil sites, fossils of a creature that moved in an entirely unique way, fossils of a creature that behaved in a very familiar human-like way, even though it wasn't a human. These fossils were found in one of the most searched areas on Earth for these things. They were right under our nose the entire time. So can you even imagine what more is out there? If you couldn't squeeze through a 7-inch gap, if Rick and Steve hadn't squeezed through that gap, we wouldn't have ever known about Homo naledi down there in that chamber. So there are many more places like that that we haven't squeezed through, that we haven't explored. The world is a big place. There is so much more about our world to discover. There's so much more about our universe to discover. And there's so much about ourselves still to discover. And so I implore you to never stop being curious. Never stop asking questions. And never stop trying to make the world a better place. And never stop exploring, right? Because you never know what you're going to find. Thank you. So I think I can take questions, right? Yeah.
So I was wondering about the caves to begin with, and I jumped to your conclusion that it must have been a burial ground.
Good,
for all
thanks.
the things
We
that
agree.
all the things that you put in there, but why were the caves there? I mean, did they dig
Yeah.
the caves for that, or were the caves there for water, or why?
No, so South Africa, this area of South Africa is fascinating, and we have geologists that we team up with and work with. So my expertise is not in geology, but you partner with people whose expertise is in those areas. So we have geologists who work with us. And the geologists have recognized that most of South Africa, or at least this part of South Africa, is built on this very, very thick, what we call dolomitic limestone. It's this ancient seabeds where animals would die, shelled animals would die, and just over time build up on the floor of the sea and build up a limestone as they're getting compressed by the water, compressed by the ocean. The Earth is a dynamic place. It changes, it moves. There's been uplift of this area, and so it's not under the water anymore. Uplift of this area, it's actually quite high elevation, and the water is acidic enough that it slowly dissolves away this limestone and turns the landscape into Swiss cheese. So there's this huge complex of caves in this area. Now the reason that people first explored this area was because in addition to there being all these caves, there is gold in this vicinity as well. And so Johannesburg was built, this South African city was built to support the gold rush, to go and look for gold in this area. Now, in addition to gold, there's limestone that can come out of these caves that's an important ingredient in making concrete and building a city. So Johannesburg was built, and while mining and finding limestone and looking for gold, people would discover these ancient bones as well. And the scientists who were working at the university in Johannesburg said, oh, that's interesting. And in the 1920s, the first great discoveries were made in this region, and people have continued to work there ever since. Yes? Go back.
So I have a question. This you barely got people down into, and given
Right.
that there's a lot of more caves out there that may be even less accessible.
Absolutely.
Is there a way that robotics could be used to get down there so you don't have to risk people?
Yeah, so that's a really good question. I don't think we're quite at that stage yet where there are places that we explore where we find fossils that are very fossiliferous and we still walk away from them because they're not the kind of fossil we're looking for, or they are preserved in a way that we're not really interested. So having a human down there, nothing beats having a human looking at this material. But there's no doubt that mapping the caves might benefit from having that kind of technology, and then knowing what is accessible and what's not, knowing what's safe and what's not, knowing where there might be a cave collapse or something like that and what's not. I would not be surprised if 20 years from now that was being employed. We also have the ability to do some underground mapping using just sonar on the surface, and that's something that has been looked into as well. Yeah, but nothing beats having a human. Even having Rick and Steve down there with those photographs wasn't enough for us, and Lee sent his son down to confirm they were in fact human fossils. So, but, the same son who had found the first fossils. Yeah. Mm-hmm.
How did you recruit, or how did the team recruit the small, I assume small women?
Facebook. It was an advertisement put on Facebook. Yep. So Lee Berger wrote up an ad saying, "I need skinny scientists," but the emphasis. I really want to make sure that the emphasis here is on what their skill set was, not their physicality. And yes, that was one of the ingredients, was their size and the ability to squeeze through this gap in the rock. But if that's all you needed, then Rick and Steve could have done the job. So it was that plus being able to excavate, knowing your anatomy, and having caving experience. The applicants came in. Most of the applicants were not qualified. They had 2 out of the 4 or 3 out of the 4 requirements, but you needed all 4. You couldn't have somebody who could excavate, knew their anatomy, and was safe in caves, but couldn't squeeze through the gap. There's a physical barrier. You couldn't have people that could squeeze through the gap, but they were claustrophobic. You had to have all 4, and these were the 6 that had the four criteria. So the advertisement was done on Facebook. It then spread pretty virally around all sorts of different kind of networks of biological sites and paleontological sites, and people learned about it very quickly. So the first, this is how quick this happened. Those bones were first photographed on October 1st of 2013. The excavation began on November 13th. So in just 6 weeks, a team was assembled to go excavate these fossils. Extraordinary. Funded by National Geographic. So you have to get the money quickly too. And National Geographic forked over the money to do this. And it paid off. Mm-hmm.
Are people still excavating at
Not right now. No, that's a really good question. So what the team leaders on this have challenged us and have said, why would we go back down there? Why would we risk the safety of people to go back down there? Give me a scientifically valid reason why we would continue to explore this cave versus just working with what we already pulled up and leaving it at that. So we're coming up with a laundry list of reasons to go down. Yeah. There's lots I still don't know about these creatures. You don't even know what question to ask before you have the fossils in hand, right? And then you have the fossils and you can say, oh, cool, I can figure out how they walked because we've got the name, we've got the hip, and we've got the foot. We can figure that out, cool. What about whether they could talk or not? Well, for that you need this bone here. It's a bone called a hyoid. And it's very different between humans and chimpanzees. And it's very rare in the fossil record to find this bone. And in fact, of the 1,600 fossils we have from Homo naledi, we don't have a single hyoid. They're down there still in the sediments. So we need a hyoid. I want to have a more complete pelvis to understand hip mechanics and birth in this species. So we don't have a pelvis yet, or of a female that's complete enough to know what the birth mechanism was like. In humans, we have this very unusual rotational birth that chimpanzees don't have. I want to know about these guys. So there are many questions we still have, and I think there's going to be good reason to go back down there. And we're building that case right now. Yes. Yeah.
For me, the fact that these creatures were using the same site to presumably dispose of their dead seems to indicate that they were staying in one place near the cave. Is there any evidence for that or any conditions looking into that?
What you just described is a very unsettling thing for us.
Could you repeat that?
The question was, the observation was that because the bodies were all found in the same site, the same place, doesn't that support the idea that maybe that was where they were hanging out, right? That was their area, and then when an individual died, that's where they disposed of their dead. Our model for how early humans were behaving, based very much on a modern human hunter-gatherer model, is that they were nomadic, they were moving around their landscape, and they never would occupy one space at any one time. And so that was sort of our model of these early creatures, and suddenly we get a site like this that suggests they're returning back to a same site over and over again. This is puzzling. And so that's an awesome question, it's a really important observation, and the question you just asked could very well be a PhD dissertation. Yeah, so if you're interested. I'm not sure how to test it. It's tough because we don't know the landscape necessarily that they were living on because we don't have evidence of them elsewhere. Once we have evidence of them elsewhere, we can reconstruct the landscape better. And if only we had some other bones down there, we could know what they were living with and maybe what they were eating. We don't have that yet. We do suspect that their teeth are so well preserved that they'll have calculus on their teeth or a little bit of plaque. And we can scrape that off, look under a microscope, and tell what kind of food they were eating. That first species I told you about, we've been able to do that. And that thing was eating fruit, leaves, and bark. So living up in the trees a lot of the time. This thing, I'm not so sure. I'm going to let him. We'll see. Let's see. Great question. Mm-hmm.
Have the rest of the 300 caves been excavated?
No, not even close. Not even close, no. So there's now kind of a team of explorers going out and checking out those sites. And as they find these caves and as they explore these caves, sometimes there are fossils, sometimes there aren't. But very often, they're finding even more caves. So you think you're checking your 300 off the list, but now the number is even higher. And the latest I heard was that there are 700 caves, 700 new caves. Now they're probably all connected to some degree underneath the ground, so it's not like 700 individual caves. There might be some connection between them, but that's all being worked out, it's all being mapped. So I mean, again, this idea, for some reason, when I talk to students about our science, very often I think there's this idea that we already know a lot about our world. That if you have a question, you can just find the answer on your phone, right? Just pick your phone and there's your answer, right? There's so much we still don't know. There's so much still to explore. So don't think we have all the answers. I think it disempowers students to present information in a way as though we know everything. There's so much we don't know. So hopefully that empowers you to go out and discover these things and realize that, geez, there's just a world out there that hasn't been explored. Yep.
Do you think that the rest of the fossils in this cave and in the other 300 are of similar structure, or do you think that they're being completely different?
That's a great question. Given that the time period involved here spans several millions of years, what we're finding at different cave sites are different species. Okay, sometimes there's overlap. So the first cave that I mentioned, discovered by that little 9-year-old, Australopithecus sediba, they lived just under 2 million years ago. So we've dated that site very well. So just under 2 million years ago, you had a creature like that. But right across the valley, a little later in time, you have different species. So we do have these different kinds of early humans, in some ways coexisting. And it's a really neat picture of evolution that's emerging, is that vision of human evolution, if I sort of say human evolution, so you think in your mind, what is human evolution? How do I visualize it? You'll probably get that image of the chimp slowly turning into the human, right? This progressional change over time. That's not how it happened. If you Google image human evolution, that's what comes up. And it's unfortunate, because that's not how it happened. Instead, we see these sort of fits and starts along the way and experiments. Lots of different ways of being a human, walking in different ways, eating different things, different combinations of anatomies. And through all that, what emerged was this. And why we survived and not the others, we don't know. And why there aren't more things coexisting with us at the time, right now. We don't know. Why are there not other species of human? We don't know, because there's one species, Homo sapiens, and that's it. And we're a rather recent species. We evolved only about 200,000 years ago. Sounds like a long time, but on this time scale, it's not. So we expect that we're going to find in this chamber, as we continue to dig, more of the same species. If we find another species, that's fascinating. And you would have the deposition of the dead in multiple species happening in the same place. That's so odd. But my guess is, my hypothesis would be that we're going to continue to find the same species. Yeah. Mm-hmm.
And Dr. DeSilva, did you say that there is evidence or there is not evidence that some of these similar species practiced this ritual of burying their dead?
Yeah.
There is evidence or there is not?
So there is the common idea in our science was that the ritualistic disposal of the dead is what Homo sapiens do. Okay. Now there's some evidence that Neanderthals did this as well. There are some sites that do look like burial sites. They look like deliberate burial of the dead. Some of my colleagues argue that it's not a real grave, that we messed up the geology a little bit, and maybe this was just a natural death of an individual who then got covered up by lakeshore sediments or something like that. There's a site in Spain called Atapuerca, where there's a pit known as Cima de los Huesos, or Pit of the Bones, and there it looks like there was the deliberate disposal of the dead down into a pit, a cave pit as well. These existed about 500,000 years ago, and they look like they're pre-Neanderthals. Their brains are about the same size as ours. And so what's unusual, and what's very odd here, and what is surprising here, is that you have that sophisticated cultural behavior in something with a brain only a third of the size of ours. Yeah, that's what's surprising. Mm-hmm.
So like you said, a lot of these humans are like part of a human tree. Is there any like evidence that some of them are closer to being primates or apes, and some of them?
Yeah. So so you got humans and chimpanzees, right? And they share this common ancestor. And then we find all these buds off the human lineage, lots and lots and lots of things that look like they're leading to us. And the reason is because they walk on two legs, and they've got tiny little fang teeth. Chimpanzees have big fangs, big canines, other primates do as well. So humans are characterized by having these small canines, large brains, they walk on two legs, and technologically savvy, so we find stone tools with these things as well. So lots of those. Gorillas are our second cousin. We share a common ancestor that's further back in time. Orangutans are the third cousin, a more distant common ancestor. Down in this time period here, from about 10 to 20 million years ago, we have fossils throughout Africa, and even fossils in Spain and France and Greece and Italy and Turkey and Hungary that are loaded with ape fossils, ancestors of all of the great apes, including us, that were living not only in Africa, but in this vast forest that once stretched into Europe and into Asia as well. But as the climate changed, and as the earth cooled and dried during some of the last ice ages, you have a receding of those vast forests back into Africa and back into Southeast Asia. And now you have essentially the extinction of animals that use that land to survive. So we do have a very good fossil record of apes, including ancestors of ours. And then what's specific to our lineage, we've got tons and tons of fossils. We don't have many fossils of chimps and gorillas, though, in part because our ancestors were living in tropical forests. Things don't fossilize well in a forest. And the fossils would likely be found in places that many researchers are not exploring right now. In Central Congo, for instance.
So I know that everyone has more questions, and that's sort of the point of this, right? Is we want to leave here with more questions than we have answers.
Good.
So let's take that exploratory spirit, and first of all, let's thank Professor DeSilva.